So hello everyone. Today we will talk about data structures like lists, stacks, queues, and priority queues. But before we need to we need to talk about the collection interface. So collection interface is an interface that defines the operations for the list, for the vectors, stacks, queues, priority queues, and sets. So this collection is a Java framework which supports two types of the container. First one is just like storing the elements in a simple way collection, and second one is storing elements in k-value pair, or in other words map. But today we'll talk only about storing elements in a simple way, in a linear fashion, and more specifically we will talk about priority queue, queue, stack, list, array lists. So collection data structure consists of the next main subtypes. So first is the sets. Sets allows to store only unique elements or non-duplicate elements. Lists allows to store elements in ordered collection, like one by one. You have already have studied like array, and the array stores elements in ordered in a linear fashion. Stack is data structure that works in the principle of the last in, first out. Queue also has a way to store this data. But it works in different principle. It works in the principle of the first in, first out order. And priority queue stores the elements based on some priorities. So here is the scheme of the collection. So as you can see, this part of the scheme is just all the interfaces that define the similar behavior for the abstract classes and concrete classes. So above everything, we have the collection, and the collection has three sub interfaces. Set, it's like a set, list, and queue. Then we have some abstract classes that implement some of the methods that is common for some concrete classes. And in the end, we have the concrete classes that implement the behavioral that was set by interfaces and abstract classes. So as you can see here, it has many concrete classes like a tree set, hash set, vector, array list, linked list, and priority queue. But today we'll talk about only about some of them. So collection interface allows to define the next common behavior or next common method. First is add. It adds elements to our collection. So it means that all the classes, all the abstract classes that inherit from the collection, they must have this method. Add all allows to add many elements at the same time, or all the elements at the same time. You don't need to add one element by other elements. You can just specify all elements and then you can add them to your collection. Remove elements from the collection. Removes all the elements from the collection, and retain all allows to store the ordering of the elements. So first we'll talk about the lists. So list is also interface, and it's we have two concrete classes that inherit from the list. Is first one ArrayList and linked list. These two data structures store elements, and they store it dynamically. So you don't need to define the size. You can just add elements on the way. Both of them provide the same method, the same behavioral, but implementation inside of the array list and linked list is different. So here is the declaration of the array list and linked list. So in order to declare array list or linked list, you have many ways. You can declare the list as a object of the list, or you can declare ArrayList like a ArrayList itself, or you can declare the ArrayList as an object of the collection. Same way for the linked list. It's you can define like as an object of the list, or as an object of the linked list, or as an object of the collection. Depending on task, some methods may miss. So if you want to use all the methods, it is better, of course, to use linked list or list. It's for linked list, and for the array, you can just declare through the list or ArrayList. So here is the code of the ArrayList and linked list. So first here it was declared ArrayList through the object of the list, and we have added 4 strings for cities, and then we just print it out. So in order to print all the elements, we can just say integer I is equal 0, while I less than the size of the list 1. And then in order to get each element by index, we can just write list1 dot get, and inside of the brackets you just write I, so you need to write index, and then it prints out the element. Same for the linked list. We have added some elements like Madrid, Tokyo, London, same elements, and then we wanted to print, and as you can see, both of them, they provide the same results and almost the same code, but again, the implementation of the ArrayList and linked list is different. So what are the difference? ArrayList is actually array, but it's a dynamically created array. So if you fill all the like capacity of the array, it copies it creates new array in different place and copies all the elements from the current array to the new array. So this is how it increases the size. Linked list, it's just used the data structure called linked list, and so we can just use ArrayList and linked list in different places. So ArrayList is necessary if we have many operations when we want to access element by index. Linked list is very good when we have many operations, when we want to add element to the beginning of the linked list or to the end of the linked list. In that case, linked list, the insertion of the linked list is faster than ArrayList. So that's why linked list get operation is not efficient. It's very time consuming because by index it works very bad. So, but if you want to print all the elements in the linked list, it's better to use this syntaxes. So for example, let's say that our linked list for the string, here instead of the list element type, you just write string s and then list, and then do some operation on each of the element. Or if, for example, our linked list was created for the integers, you can just, instead of string, you can write integer. Next is the queue interface. So if we go back to the scheme of the collection, here we have the interface queue, and we have 2 concrete classes that implement the queue. It's the first one is linked list, and second one is priority queue. So again, queue is data structure that works in the principle of the first in and first out. So if you want to just implement simple queue, you can implement it through the linked list. Second is priority queue. It works with the principle with some priorities of some specific elements. But first, let's talk about the queue itself. So queue, again, as I said before, it works in the principle of the first in, first out. And here it has the next methods. Offer, it adds element to the queue. Poll, it retrieves and removes the first element in the queue. Remove, it removes the first element in the queue. Pick, it just retrieves the first element, but it doesn't remove. And element, it also retrieves the element. If the element doesn't exist, it throws exception. The difference between pick and element is that if element doesn't exist, if any element doesn't exist in a queue, pick returns null. But element returns exception. So here is the implementation of the queue. In order to declare the queue, we need to write queue string. Here, this is the name of the queue, and new linked list. Again, linked list is a concrete class. Queue is the interface, and here we use method offer. We added Oklahoma, then we added Indiana, then we added Georgia, then we added Texas, and then when we print all the elements, it prints in the element that was added first. So first it prints Oklahoma, Indiana, Georgia, and Texas. Again, it works in principle of the first in, first out. Now next is priority queue. If queue stores the element in the first in, first out, priority queue stores element based on some natural ordering. So it stores elements. First, it stores elements with a list value. So for example, in order to declare the priority queue, we just need to write priority queue, for example, and then string, the name of the priority queue, and then new priority queue. And then we have added the same strings, Oklahoma, Indiana, Georgia, Texas. And when we print the elements in priority queue, it first prints Georgia, Indiana, Oklahoma, Texas. Why like that? Because it sorted the element based on the alphabet of the first letter. So the first letter of the Georgia stays higher than the first letter of the I, of the Indiana, which is I. And the I is in alphabet is higher than O in Oklahoma, and O is higher than Texas. So it sorted the element based on the alphabet, or in other words, based on the list value. So for today's summary is like this, that Java collection supports many data structures. If to be more specific, it's a set, list, queue, and maps. For today, we just explored the lists, and we have discovered data structures like ArrayList or linked list. And the difference between ArrayList and the linked list is that ArrayList is a resizable array, and the linked list is the implementation of the linked list data structure. So that's it for today. See you. Bye.